Now we're going to solve a rational equation. I said we're solving rational expressions. I meant equations. Okay. So what we could do here, okay, is if we've got things that are added up, for instance, well, it's a subtraction, it's almost the same thing. We could add the fractions together, okay, using the LCD, okay, like we did before. Okay, so this is the previous example. You recognize I've used the same fractions. But one cool thing too is that we could use the LCD to clear the fractions. So I'll show you what that technique. So we figure out the LCD. So we did that before. Well, maybe just to remind you, this is, you're going to need to factor first to figure out your LCD. So x minus 2, x plus 2. Okay, so the LCD, okay, LCD is here x plus 2 squared, x minus 2. Now, the technique that clears the fraction is that we're going to multiply on both sides by the LCD. Okay, so multiply on both sides by the LCD. So how does that work? Well, on one side we've got 0, so that's not going to be a big deal. Multiplying by 0 is going to still give us 0. But we're going to multiply by the LCD here, x plus 2 squared, x minus 2. But if we'd have other stuff here, and with fractions, that it would include the denominators to figure out our LCD. We'll multiply on both sides by the LCD. But here, since it's 0, okay, multiplying anything by 0 will give me 0. So if I multiply by the LCD, notice what's going to happen. So I multiply this by this. So I've got the x plus 2 squares are going to go away. So I'm going to be left with 6 times x minus 2. So no fraction. That's the idea. When you multiply by your LCD, the fractions are going to be gone. And here, when I multiply this by this now, x minus 2 and x plus 2 are going to go away. And there's going to be one factor of x plus 2 left at the top. So I'm going to be left with this. And now there are no fractions. It's just a polynomial equation, like super easy to solve. So what you do is, you group like terms. Minus 16 equals 0. You factor maybe. And there's something you may want to apply here, a basic principle. If you've got a times b that is equal to 0, that means that either a is 0 or b is 0, right? Now, this is like our a, this is like our b. Now, a is clearly not 0, it's a constant. So that means that x minus 4 must be 0. Maybe it sounds kind of stupid. Maybe you could tell me, I would just divide on both sides by 4, but this is a principle we're going to apply in more complex cases. So I just want to show you that it still applies in that case. So we get x equals 4 as a solution. Now be careful. We need to figure out if 4 is a solution by replacing initially into the initial equation, because it could happen that 4 divides one of the fractions and you can't divide by 0. What I meant here is it could happen that if you replace x by 4, one of the fractions is going to be divided by 0. So you have to check if you replace x by 4 in the first fraction here and the denominator here. Will you create a 0? No. And here, no. Okay. But if I would have obtained, like, say, 2 for a solution, it would have canceled. It would have canceled the second denominator, and we would have had like a 2 over 0, which is impossible. So you have to be careful with your solutions. You have to verify that they actually work. So this is solving a rational equation.